Good morning, I am Devasena. In this lecture, we are going to discuss about Y parameters or short circuit admittance parameters. This topic is present in the subject circuit analysis under the unit two-port networks. Let us discuss the Y parameters in detail. Y parameters are also called admittance parameters. These are obtained by expressing currents at two ports in terms of voltages at two ports. Thus, voltages V1, V2 are considered to be independent variables and the currents I1 and I2 are considered to be dependent variables for this Y parameter because Y, that is, the admittance is the ratio of current by voltage. The term that is present in the numerator is considered to be the dependent variable, while the term that is present in the denominator is considered to be the independent variable. In this admittance, that is, Y is the ratio of I by V. So, the current is considered to be the dependent variables and voltage is considered to be the independent variables. Thus, we have I1 is equal to the function of V1 and V2. That is, current I1 is the function of voltage at the input port and the output port. Similarly, I2 is the function of input voltage and the output voltage, that is V1 and V2. In equation form, these relations can be written as I1 is equal to Y11 V1 plus Y12 V2. Consider this as equation 1. And I2 is equal to Y21 V1 plus Y22 V2. Consider this as equation 2. In matrix form, the above relations can be written as, this is the matrix representation of the two equations 1 and 2. That is, matrix of I1, I2 is equal to matrix of Y11, Y12, Y21, Y22 into matrix of V1, V2, or determinant of I is equal to determinant of Y into determinant of V. The individual Y parameters can be obtained by assigning value of the independent variables. Let V2 is equal to 0. That is, port 2 is short circuited. From equation 1, we have I1 is equal to Y11 V1 because the term Y12 V2 is considered to be 0. Therefore, Y11 is equal to I1 by V1 at V2 is equal to 0. The unit of Y11 is mho. The parameter Y11 is called short circuit driving point input admittance because it is the ratio of input current by input voltage. That is, Y11 is equal to I1 by V1. From equation 2, we have I2 is equal to Y21 V1 because the term Y22 V2 is considered to be 0. Therefore, Y21 is equal to I2 by V1 at V2 is equal to 0. The unit of Y21 is mho. The parameter Y21 is called short circuit forward transfer admittance because Y21 is the ratio of I2 by V1. I2 is the output current and V1 is the input voltage. That is why it is called as forward transfer admittance. Let V1 is equal to 0, that is port 1 is short circuited. Therefore, from equation 1 we have I1 is equal to Y12 V2 because we considered V1 is equal to 0. Therefore, Y12 is equal to I1 by V2 at V1 is equal to 0. The unit of Y12 is mho. The parameter Y12 is called short circuit reverse transfer admittance because Y12 is the ratio of I1 by V2, that is the ratio of input current by output voltage. Therefore, it is called as reverse transfer admittance. From equation 2, we have I2 is equal to Y22 V2 because the term Y21 V1 is 0. Therefore, Y22 is equal to I2 by V2 at V1 is equal to 0. The unit of Y22 is mho. The parameter Y22 is called short circuit driving point output admittance because Y22 is the ratio of output current by output voltage, that is I2 by V2. Moreover, these parameters are defined individually only when the voltage in one of the ports is 0. This corresponds to the condition that one of the ports is short circuited. Hence, Y parameters are named as short circuit admittance parameters. The equivalent circuit of a two-port network in terms of short circuit admittance parameters satisfying equations 1 and 2 is shown in figure. This is the equation. Equation 1 is I1 is equal to Y11 V1 plus Y12 V2. Equation 2 is I2 is equal to Y21 V1 plus Y22 V2. The representation of the equivalent network of a two-port network in terms of Y parameter.